Hello there. Welcome to my YouTube channel. Today I will take you through heat conduction through a composite wall and heat transfer. Let's tackle this question. Find the heat flow rate through the composite wall as shown below. Assume one-dimensional flow. Thermal conductivity Ka equals 150 watts per meter per degree Celsius. Thermal conductivity Kb equals 30 watts per meter per degree Celsius. Thermal conductivity Kc equals 65 watts per meter per degree Celsius. Thermal conductivity Kd equals 50 watts per meter per degree Celsius. Solution. Here is a diagrammatic view. Given. Thickness La equals 0.03 meters. Thickness Lb equals thickness Lc, which equals 0.08 meters. Thickness LD equals 0.05 meters. Finding the areas perpendicular to the heat flow. Area AA is equal to 0.01 square meters. Area AB is equal to 0.003 square meters. Area AC is equal to 0.007 square meters. Area AD is equal to 0.01 square meters. Finding the thermal resistances. Thermal resistance of A equals 0.02. Thermal resistance of B equals 0.89. Thermal resistance of C equals 0.176. Thermal resistance of D equals 0.1. Finding the equivalent thermal resistance for the parallel thermal resistances. Equivalent thermal resistance BC equals 0.147. Finding the total thermal resistances. Which equals 0.267. Finding the heat flow rate Q. Which equals 1273.4 watts.